So here is our first problem. Determine the moment of the force F about the point A from the figure below or given figure flashing now in your screen. So first, we are going to determine the moment of the force about point A. So our formula here is m sub A vector R times, cross F, force F. So first, we are going to know that the um, the force here in the upper corner, it has a 3 uh, 3 in the y-axis and 4 in the x-axis, or a slope of 3 over 4. Slope of 3 over 4. And first, next is we're going to find the components of F. So the components of F, force F, um, F of x is equal to negative 200 pounds times 4 over 5. And what we have here is negative 160 pounds. Next is the force y, or F sub y, 200 pounds times 3 over 5. So what we have here is 120 pounds. In terms of z axis, we don't have a force since it is a two-dimensional force. So now we have the components. Next is to find the r vector, or vector r, from point A to point B. So our r here is from point A to point B, negative 4. Why negative 4? Because it is going to the left from the x-axis. So I hat plus 6j hat. So why 6j hat? So it is going up in the positive direction. And next is we are going to solve using vector solution. So since we have the r vector, this will be I, j, k. And for the r vector and the f force, so negative 4, 6, 0, negative 160 pounds, 120 pounds, 0 pounds. So if we solve this, using we can cross here. So this is equal to quantity 6 times 0 minus 0 times 120, quantity for the I hat. So continue here, and we have quantity 0 times negative 160 minus 0 minus times 4. This is negative 4. Negative 4 for the j hat plus quantity negative 4 times 120 minus 6 times negative 160. This is for the k hat. So if we are going to solve this, our moment of force about A is 480 k pounds inch, or 480 pounds inch. That's all. So for the second problem, from the figure flashing on your screen, compute the tensile force in each chords A, B, and D. So first is we are going to equate summation of x is equal to 0. So what we have here is D cosine 15 degrees minus C cosine 60 degrees. As you can see, and as you observe in the figure. Next is the summation of y is equal to 0, D sine 15 degrees plus C sine 160 degrees minus the weight, 400 pounds. This is pounds. Next is we're going to isolate D. We can choose either this equation or this equation. So we choose this equation from the top. So D is equal to C times cosine 60 degrees all over cosine 15 degrees. Then next is we are going to apply um, this d to the second equation, or solve this simultaneously. So what we have here is c cosine 60 degrees sine 15 degrees plus c sine 60 degrees times cosine 15 degrees all over cosine 15 degrees. This is all equal to here 400 pounds. Uh, and if we calculate this, what we have here is c is equal to 400 pounds. Continuing the problem, since we have the c valuable, we can input this c value to the d equation. So d will be equal to 400 pounds times the cosine of 60 degrees all over cosine 15 degrees. So what we have here, d is equal to 207 pounds. That's what we are going to find. So this is the first answer. Next is to find b and a. So first is equate x, summation of x is equal to 0. So what we observe here is we can get this equation, negative b cosine 75 degrees. This is long. A cosine 60 degrees, 60 degrees plus 400 pounds and plus 300 pounds cosine negative 30. So I have a guide here flashing on your screen that I have solved the FBD or some corrections from the given figure, or some guides in blue broken lines. And next is the second equate summation of y is equal to 0. So b sine 75 degrees minus a sine 60 plus 300 will be times the sine 30 sine. This is sine 30. I cannot fit this. Let's move it here. Sine 30 degrees. So first is we need to equate we need to isolate b either from this equation or this equation. So I've chosen the equation at the bottom. So b is equal to 300 sine 30 degrees plus a sine 60 degrees all over sine 75 degrees. So now we have the b equation. Okay, next is we have here is 400 pounds plus 300 cosine negative 30. Since we plug in b to the x summation earlier, so let's continue. A cosine 60 degrees minus a this one, a sine 60 degrees times cosine 75 degrees all over cosine 75 degrees, and this is equal to 300 sine 30 degrees. So we have here the equation, and if we equate this, next is that a will be 300 pounds times sine 30 degrees times cosine 75 degrees. This was derived from the previous equation for to isolate a, or to find a. Cosine 60 degrees minus sine 60 degrees times cosine 75 minus this continuation, minus 400 plus 300 cosine negative 30. If we solve this in your calculator, what we got here is 845 pounds. So we got a value. So since we got the value of a, next is we need to plug in this value to the b equation. So b is equal to 300 sine 30 plus the A, 845 pounds, times sine 60 degrees all over, sine 75 degrees. So what we have here is 913, this is 13, 913 pounds estimated. So we've completed the values of A and D. Correct. So here is our last problem. The upper beam presented in the figure showing now in your screen is supported by a reaction at resultant 3 and a roller at A, which separates the upper and lower beams. Determine the values of the reaction. So first, as you can see in the figure flashing now, we can equate the moment of the force R3 at point at the point where is it reacting to. So this will be mr3 is equal to 0. And okay, so we are just focusing on the at the upper beam. So if we count from the point R3 to the end of the it is 14 feet. So from R3 to RA, it has 10 feet. So we have here is 10 feet times the moment of A, RA, minus 600 pounds times the 400 of 14 feet, minus the 1900 pounds to the left, 4 feet to the left. Okay, equate this to 0. So if we transfer this to the right side, these two terms we got, and solve this, we have the reaction A, 1600 pounds. To continue to find the R3, so if we if we total the forces or vertical forces from the upper beam, so the sum of Fy is equal to 0. So what we have here is Ra plus R3. This is going upward, and equals to 600. Since it is going downward and it is the other side of the transpose, it was transported transposed or already, so it will be positive. So plug in a Ra. So what we have here is R3, or force or reaction force, R3 is equal to 600 plus 1900 minus 1600. So our R3 here is 900 pounds. Okay, we got the two forces. Next is for the second beam, or the lower beam. So let's see. Let's say if we have a clockwise, let it be positive, and let one of the forces be equal to 0, so that we can isolate one force. So we have the R1. We selected the reaction force 1 to 0. So what we have here is 4 meters to its right. So 4 meters times 4,000 pounds, minus R2. It is 10 feet from our point, and plus 1600 times 14 feet, which is the reaction A. So what we have here, this is going down from its reaction. RA can point up, going up its force in the upper beam, and going down in the lower beam. So next is if we get this, we can isolate R reaction 2, or the force R sub 2. So force R sub 2 is equal to 3,840 pounds. lastly is we are going to total the all vertical forces. So the sum of f sub y is equal to 0. This is in terms to the second beam. Equal to 0, 4,000 pounds plus 1,600 pounds is equal to R2 plus R1. Since R1 is missing, we can isolate the R1. So R1 is equal to, our R2 here is 3,840. So 4,000 plus 1,600 pounds minus, we transpose this, 380, I mean 3,840 pounds. So what we have here, our R1 here is 17 hundreds, I mean 60 pounds. R1, R1, R3, our RA, and our R2. So we've completed the problem.